Ken, you're all set.
Okay, great. So hi judges, my name is Maggie and I'm a 16-year-old who's interested in biotech, and my team and I are really excited to share our moonshot idea with you guys. So thank you for being here. Whether you're a student studying for exams, an employee trying to further their career, or a first-time parent bringing home a newborn baby, the one thing we all have in common is sleep, or lack thereof. And in our modern society, we're getting less and less of it. In fact, a 2019 survey found that the average adult is getting only 5 hours and 30 minutes of sleep each night, when the recommended is 8. But what if there was a way we could get all the cognitive benefits of sleep, but in half the time? Introducing Somna, a solution that involves inserting genetically modified neuron receptors into your brain and activating them using Somna's ionized water. That essentially means that each night before going to sleep, you can just drink our ionized water and enhance your sleep quality while minimizing sleep time. So the way that we think about sleep is that there are two types of sleep. There's non-REM and REM, and they both play an important role in memory consolidation, brain repair, as well as ensuring that you're ready and fresh for the coming day. So each night when you go to sleep, you cycle between 4 to 6 sleep cycles. And what we're proposing is to cut down the number of sleep cycles in half, and instead lengthen the amount of time that you spend in non-REM and REM, so we can cut out all the intermediate stages that are involved to cycle back and forth. By doing so, we can maximize sleep quality and by extension, minimize the amount of time that is necessary for sleep. So the way that this works, you can kind of think of it like a lock and key. You need to have the correct key in order to unlock your house door, or you're just going to be waiting at the doorstep. In the same way, once we have our receptors in our target neurons, all we need is our key, CNO, to be present. And when it's able to bind to those receptors, we can unlock the mechanisms behind sleep. So the way that we can actually get these receptors into their target locations in the first place is using a non-invasive surgery method called acoustically targeted chemogenetics, or ATAC, and it has 3 key steps. The first is injecting an adeno-associated viral vector, or an AAV. And essentially, these viral vectors will contain the genetic information that encodes for our receptors. However, just injecting it doesn't ensure that it gets to its target location. So we would need to use focused ultrasound to open up the blood-brain barrier, which is a mechanism that prevents any unwanted substances from entering the brain. Once we're able to bypass this mechanism, these viral vectors can enter the brain and insert these receptors into their target locations, which are neurons that regulate sleep. So the specific ones we are thinking of targeting are GABAergic, glutamatergic, and dopaminergic neurons. Once the receptors are there, we can activate it using Somna's ionized water because it contains a special activator molecule called clozapine nitric oxide, or CNO. However, for this to become a reality, there are still several limitations we have to overcome. The first thing is that chemogenetics has never been done in humans before, and nor is it FDA approved. As a result, we would need to do a lot more studies to ensure its safety and to create a standardized procedure for future therapeutic treatments. Additionally, even though I mentioned several different neuron targets we would want for this solution, sleep is such a complex phenomenon, and there's no doubt a bunch of other elements in neurons that are implicated in this process. As a result, we would need to do a lot of research to confirm all these targets and look at all the interactions to maximize sleep quality. And finally, since this is a new technology, there's a lot of unknown long-term side effects. One thing that our team considered was that even if we were able to successfully insert these receptors and activate it using the ionized water, one potential thing is intolerance, meaning that continued activation of specific receptors might make it less effective. However, if we were able to overcome all these technological gaps, we would be able to create a healthier and happier society. Each year, $600 billion are lost due to sleep deprivation in the workplace. If we were able to employ this solution, we would be able to help workers have better work-life balance. And as a result, they'll have greater productivity and we can boost the economy in the long run. Ultimately, Somna is trying to create a world where no one has to sacrifice sleep in order to pursue the things that truly matter to them. With these 4 extra hours, people can choose how they want to invest it, whether it's spending more time with their friends and family, pursuing passion projects, or even traveling the world. What Somna is trying to do is not just to boost standard of living, but boost quality of life, so people can find greater satisfaction and meaning in their lives. And by doing so, we can minimize sleep and maximize life. Thank you. And I would like to introduce my team, which helped make this entire project possible. Thank you.